So scale factors are really important, all right? Now, if we're looking at scale factors for length, okay, then the scale factor that you're looking at will be like to the power of 1, okay? The scale factor, say the scale factor was x, so it could be like 2. If we're looking at areas, then it'll be the scale factor squared, okay, the scale factor for length squared. If we're looking at volumes, it'd be the scale factor for length cubed, okay? And this kind of links in quite nicely. So it says work out the volume of solid B, okay? We've got our 2 diagrams, okay? And I can link them using the 2 numbers 3 and 6, okay? So first of all, I'd work out the scale factor for length using 3 and 6. So 6 divided by 3 is 2. Yeah, so that's the scale factor for length. If we're looking at volume, the scale factor for volume will be 2 cubed, which is 8. Okay, now if the volume of A is 60, then the volume of B will be 60 multiplied by 8. Okay, which will bring you up to 480 centimeters squared. Okay, so solid B has a total surface area of 140. Okay, let's first of all kind of sort out my scale factor for area. Well, it's the scale factor for length, which is 2 squared, so that'll be 4. Okay, if B was 140, we're kind of going backwards, so instead of timesing, so I'd say, well, the scale, the surface area of, I don't want to use the same notation that I'm using, write it out, surface area of A would be the surface area of B, which is 140, divided by your scale factor, which is 4. And that'll bring you to 35 centimeters squared. So it's really important that you understand the links between surface scale factors and length, areas and volumes, because on some of the questions, particularly towards the end, you're going to have to use one of them to find out the scale factor for length first, then to find out the scale factor for either area or volume, depending what it's asking for.